Hi everyone, welcome back to the series 250 most important questions. This is the 8th session. I hope you guys are solving on a daily basis. It's important to solve on a daily basis because if you keep missing each of them, it might become a big backlog later on, okay, and you might feel like you have too much to do at once, okay. So at least try to do maybe 5-10 questions, whatever is possible from this series every day, okay. It won't consume a lot of time and it will keep you in touch with IPMAT, okay, and all the concepts that we are doing. We will start with the homework question first and then we will go to the rest of the questions, okay. If you want to take the IPMAT crash course, it is starting from 29 March, okay. You can take it, and as I keep saying, you need to practice more at this point of time. So go to the playlist section, you will find a lot of playlists of quant, verbal, logical, DI, all the topics, okay. So this is the question that I gave you for homework. Let's try this. For a 4-digit number greater than 1000, it's a 4-digit number greater than 1000, okay. Sum of digits in the thousands, hundred and tens place is 15, okay. Sum of the digits in the hundreds, tens and units place is 16. Also, a digit in the tens place is 6 more than a digit in the units place. The difference between the largest and the smallest possible value of the number is, okay. It's a 4-digit number, let it be A, B, C, D, okay. We have been given that it's a number greater than 1000, okay, make sure. Now, sum of the digits in the thousand, hundred and tens. So, thousand, hundreds, tens. So, sum of A plus B plus C, it is given how much? 15. Sum of the digits in the hundreds, tens and units place, hundreds, tens, units place, that means B, C, D, it is 16, given to you 16 over here. Also a digit in the tens place is 6 more than digit in the units place. So, digit in the tens place is C, that is 6 more than digit in the units place is D, D plus 6, C will be D plus 6. I hope this much is clear. Now, the difference between the largest and the smallest possible value of the number is, you have a couple of equations here, okay. If you think about making this the largest, many of you might think that I will put A equals to 9 and then I will deal with the rest of the things, okay. That won't work here because there will be too many combinations. If you put A equals to 9 here, B plus C will be equal to 6 and there will be so many variations, okay. So, what you should do here is, you know that you have two equations A, B, C, B, C, D. Can we just deduct the second equation from the first? We will get A minus D equals to minus 1, or we will get D equals to A plus 1, isn't it? Can I say that D is A plus 1? So, can my number be written like this, A, B, C, and D can be written as A plus 1, obviously, because I will try to minimize the variables, isn't it? Now, C is given D plus 6, D is this A plus 1, so C will be A plus 1 plus 6, that means A plus 7, so number will be A, B, A plus 7 and the last digit would be A plus 1, right. Now, you have less variables to deal with. You know that it's a 4-digit number greater than 1000, okay. You see here that we have A here, B here, A plus 7 and A plus 1 here. So, can I start with A plus 7, because if I put values for A over here, what are the values that A can take? Can A take 0? No, because if A takes 0, the first digit here will be 0 and it won't remain a 4-digit number. So, A cannot be 0, okay. Can A be 1? Yes, A can be 1. In that case, the number would be 1, B we do not know, okay. 1 plus 7 is 8 and 1 plus 1 is 2, right. Can A take value 2? Yes, if A is 2, B 2 plus 7 9 and 2 plus 1 is 3. Can A take 3? No, because if A takes 3, this third digit becomes 3 plus 7 10, 10 is not possible, okay. Digits have to be of single digit, I mean these will be single digits, okay. You cannot have 10 as a digit, right. So, that means only 2 numbers are possible over here, but then now what you have to do is, you know that only 2 numbers are possible over here. Obviously, this is the greater one because this is 2000 something, this is 1000 something, this is the largest number and this is the smallest possible number, right. But we still have to find out the value of B, keeping in mind these equations, okay. What is this? A plus B plus C should be 15. So, A, B, C should be 15. 8, 1 is 9, B should be 6, isn't it? Then only this will be 15. And is it also satisfying B, C, D equals 16? 6 plus 8 plus 2 is 16, yes, correct, okay. And this, and similarly we have to find B over here, so that the sum of the first 3 is 15. So, 9 to 11, B should be 4 and this should also satisfy 4 plus 9 plus 3 equal to 16, yes, doing that, okay. So, the largest number possible is 2493, the smallest possible is 1682. What is the difference? It will be 118, 811, that is your answer, option C. Okay, so it's a good question, and there are high chances that such a question can come. Okay, it's a perfect IPMAT level. To some of the students, it might would have been very easy, but it is a question in which there will be so many cases. Some of the students might have got a different answer. Okay, now we'll talk about this. Let ABC be a triangle with AB equals to 3, BC equal to 4, AC equal to 5. Now we have solved so much that we can straight away say that this is a right angle triangle. Okay, this is a right angle triangle. So this is 3, this is 4, this is 5. So obviously this will be 3, 4, right angle, and then 5, right. So this is A, B, and then C. Let I be the center of the circle inscribed in ABC. In ABC you have to inscribe a circle. Let this be the circle. That means this is in circle, okay, because it is touching all the sides of the triangle internally. Okay, what is the product of AI, BI, CI? I is the center of this circle. So this is I, right? This is I. You need the product of AI, BI, and CI. Let's see how to do this. Okay, you know that this is the in center because it is the center of the circle which is touching all the three sides of the triangle internally. In center. If we have the in center, can we find out in radius as well? Yes. So you all know that in radius is area upon S. You know this formula, right? What is S? S is semi perimeter. That means half of the perimeter of the triangle. R is in radius. Area is half base into height because this is a right angle triangle. So R will be area half base height upon semi perimeter. Semi perimeter is the perimeter and half of that. 5, 3, 8, 8, 4, 12. 12 by 2 is 6. So half of 3 into 4 is also 6. 6, 6 gone. R will be 1. If R is 1, then you know that from the center I, if you drop a perpendicular here, yes or no, it will be 90 degree because see now C and this point, let me say that this point is D, this point is E, and this point is F. D, E, F are point of contact of tangents. So AC will be a tangent at point F, BC will be a tangent at point D, and AB will be a tangent at point E. Clear? So at the point of contact of tangent, this is 90 degree, this will also be 90 degree. You know that this radius, in radius is 1, so this much will be 1. If this entire thing is 4, this is 1, so this part will be 3, isn't it? DC will be 3, okay. Now you know that from a point, if you draw tangent to the same circle, right, they are equal. From an external point C, you are drawing two tangents, CF and CD to the same circle, they will be of equal length. So if this is 3, this is also 3. If this is 3, this entire is 5, so this will be 2. If this is 2, this is also 2. And if this is 1 from this point, you see that this is a tangent, BD, BE will also be 1. But you still have to find out CI, BI and AI ka product, right? So what do you see here? This is a right angle triangle. You have the base 3 here, you have the perpendicular that is 1. So 3 square plus 1 square under root, 9 plus 1 root 10. So this will be root 10, right? Over here, what do you see? This is 2, right? This is 1. So this AI will be what? Under root of 2 square plus 1 square, that means root 5. And finally, here you need BI. So this is 1, this is 1, this is 90 degree, root 1 plus root 1 plus 1, that means root 2. So this will be root 2. You have AI equals to root 5, BI equals to root 2 and CI equals to root 10. You need their product. Root 5 into root 2 is root 10 and root 10 into this root 10, that basically gives you 10 and that's your answer. So 10 will be the answer, okay. So this is a very good question again of perfect IPMAT level, and you know that in radius, circumradius, these are IPMAT favorites, okay. I hope the question is clear. Let's go to the third one. Let us take a point P inside an equilateral triangle. The sum of lengths of the perpendiculars dropped to the three sides of the triangle is equal to 1000. Then the length of the altitude of the triangle is altitude of the triangle, okay. So we need an equilateral triangle, okay. So this is your equilateral triangle. The sum of lengths of the perpendiculars dropped to the three sides of the triangle is equal to 1000. Now P is a point inside the equilateral triangle, okay. So say because he has just mentioned that P is a point inside the equilateral triangle, you just take it over here, okay. Say this is P. The sum of lengths of the perpendiculars dropped to the three sides. So from here, if you drop a perpendicular, it is like this, from here it is like this, and from here it is like this on the three sides. Sum of these three perpendiculars, say this is A, Now see, because he has mentioned that the point is inside the equilateral triangle, and this is a perfectly symmetrical figure, symmetrical case, because in equilateral triangle sides are equal, internal angles are equal. So I will also take my point in such a way that things are easier for me. So I have taken this point exactly in the center of this, okay, exactly in the center of the equilateral triangle, okay. So can I say that this length will also be A, this will be A, this will be A? Obviously, because if you draw a circle inside this, if you draw a circle inside touching all the three sides of the equilateral triangle, this will be A, because these are radius of the in circle, right. So sum of these three is A plus A plus A will be 1000. So A will be 1000 by 3, fine. But the question is then the length of the altitude of the triangle. You know that if you have an equilateral triangle like this, and from here if you put down the altitude, right, that means a perpendicular from this side to this side, right. In an equilateral triangle, if from any vertex you drop a perpendicular on the other side, it will bisect it. Similarly, from here if you drop a perpendicular here, this will be bisected. From here if you draw a perpendicular here, this will be bisected as well. Now, what do you call a line which starts from a vertex, goes to the opposite line and bisects it? It is median. So, this is perpendicular bisected and we can say that it is median. What is the point of intersection of the medians? These are three medians. What is their intersection point called? It is called the centroid. Now, you know that if I join these, okay, like this, obviously this will go like this and this will go like this. So, actually I have taken point P at the centroid, yes or no? You know that whenever we have the centroid, it divides. So, if this is the centroid, you know that the centroid divides the median. So, try to understand this line, let me change the color, it is the white line that I am talking about. This white line is my median. This point is the centroid. The centroid divides the median in ratio 2:1. I hope this is clear, and just moments ago you got that this is A. So, if this is A, this will be 2A, and he wants us to find out the length of this altitude, which will be 2A plus A, that means 3A. You just got A as 1000 by the 3, so 3 into 1000 by 3, this cancels, you get 1000. 1000 is your answer. So, I hope this is clear. This is possible because it is a perfectly symmetrical case, okay. Many of you might be thinking we could have taken this point P over here. So, let me tell you there is a proper theorem around this, okay. If inside an equilateral triangle you take a point P and then from P you draw perpendicular to all the sides, their sum will always be equal to the length of the altitude, okay. That is a proper theorem, you can search for it, but this is how we do it, okay. If we take a point exactly at the centroid, that means middle or center, okay. In such questions you should take a case which is easy for you, okay. Do not distort the figure, do not take the point here and there, because it says that the point can be taken anywhere on the equilateral triangle, you can take it, okay. I hope that is clear. Now, let us talk about this particular question. What is this? This is for how many integer n with n between 2 to 80 is n minus 1 into n plus 1 by 8 equal to an integer. So, n minus 1 into n plus 1 divided by 8 must be integer. This will give us an integer when the numerator is completely divisible by 8, yes or no? We see that here we have n minus 1 into n plus 1, so can I write it as n square minus 1 into n upon 8. Now, there is an interesting thing about n square minus 1, okay. If you put even value of n over here, so you have to start from 2, put 2, you get 2 square, 2 square is 4, 4 minus 1 3, 3 into 2 6, 6 divided by 8 not divisible. If you put 3 here, n equals to 3, 3 square minus 1 is 8, 8 into 3, I mean you get an 8 over here, yes or no. So, when you put odd number n equals to 3 here, so 3 square minus 1 is 8, which is multiple of 8. Similarly, if you put 4 over here, which is even, 16 minus 1 is 15, 15 is not divisible by 8. But what if you put 5, 5 square is 25, 25 minus 1 is 24, 24 is a multiple of 8. That means, whenever we are putting n equals to 3, 5, in fact, you check with 7, 9, 11, check for each and every odd number in this range, you will get to know that n square minus 1 is always divisible by 8 when n is odd. So, count all values, odd values from 3 till, you have to go till 80. So, last odd number would be 79. This is an AP having difference 2. So, an last term is equals to a plus n minus 1 into d. Okay, difference is 2, right? So 76, 38, n equals to 30, and there will be 39 such odd values of n over here. Clear? But this is the case where we just checked n square minus 1. What about this n? Obviously, when we have odd values, this n will not be divisible by 8, while this part will be divisible by 8. So, what are those values of n? If we put it here, it is divisible by 8, definitely a multiple of 8. So, what are the multiples of 8 that we have? We start with 8 because between 2 to 80 we have 8 first, then 16, and what is the last multiple in this range? It is 80 itself, because we can include 80 because it is equal to 80. So, last term is equals to a plus n minus 1 into difference is 8. So, 72, 9, n is equal to 10. There are 10 values of n which have to be multiple of 8, while 39 values, odd values of n, which will completely divide the numerator by 8. Hence, 39 plus 10, total such values will be 39 plus 10, 49. 49 is the correct answer to this question. So, this is an important result, okay? N square minus 1 is divisible by 8 when n is odd. Always remember this. Let us go to the next question. ABCD is a 4-digit perfect square number. If each digit is increased by 3, the new number formed is still a 4-digit perfect square. Find the product of the digits of the number ABCD. Product of digits of ABCD. Okay, so both of them are perfect squares, okay, because earlier we had a perfect square, we increased each digit by 3, we got another perfect square. So, let me say that this first perfect square is in form of x square, this will be in form of y square. So, y square minus x square. I mean, obviously, if there is a perfect square, say you are increasing each digit by 3, isn't it? So, suppose you had a perfect square like this, say 1024. If you increase each digit by 3, what will be the value that you will be getting? 4, 3, 5, 7. What is the difference between these two? Obviously, 3, 3, 3, 3, right? So, difference between these two perfect square is 3, 3, 3, 3. If you find out the difference between these two, it will be 3, 3, 3, 3, right? So, we know that there are two perfect squares having a difference of 3, 3, 3, 3 in between, okay? Y square minus x square can be written as y plus x into y minus x, obviously. And obviously, 3, 3, 3, 3 can be factorized like this, 3 into 1, 1, 1, 1 first. This is divisible by 11, so 3 into 11 into 101. Right? I hope that is clear. So, this can be factorized like 3 into 11 into 101, this number. Now, there are two numbers that have a product of this. So, we definitely we do not need 3 numbers over here, this cannot be factorized further, okay. What all pairs are possible? Obviously, 3 into 1, 1, 1, 1 will be possible, then 11 into 303 will be possible, then 33 into 101 will be possible, right. I hope that is clear. And then 1 into 3333 is possible, 3333 into 1 is possible, right. Now, what do you know here? These are two numbers which are having a product of 3333. So, two numbers you can take 1 into 3333 first, right. What you have to do here now is, see, y plus x obviously will be a bigger number because this is addition of two numbers. Y minus x will be a smaller number. So, give the bigger value to y plus x, smaller value to 1. And if you add them both, you will be getting some value of y, right, and you will be getting some value of x when you solve both. Obviously, when you add y plus x equal to 3333, y minus x equal to 1, you add them both, x will be cancelled, 2y will be 3334. So, y will be a 4-digit number, right. Y will be a 4-digit number. So, if y is a 4-digit number and if you square it, obviously you have to square y to get a 4-digit number, right, because perfect squared number, 4-digit perfect square number is y square, not y. So, you will, if you square, if you get the value of y here, if you solve both equations, because obviously y plus x will be 3333 and y minus x will be 1. You add them both will be cancelled, 2y will be equal to 3334. Obviously, y will be a 4-digit number here, yes or no? If you square that 4-digit number, it becomes a bigger number, bigger than 4 digits, right. So, that means this solution will not be taken, this will be cancelled, this will be cancelled, okay. In the same way, we will be doing these as well, okay, 3 into 111. So, y minus x will be 3, y plus x will be this. If you add both, 2y will be 1114 and x will be a 3-digit number, y will also be a 3-digit number. If x or y is a 3-digit number, you square it, it will become greater than what? It will become a number greater than 4 digits. So, this is also gone. Okay. What about 11 into 303? So, 11 into 303, you will be getting 2y equals to 314, y will be equal to 157. 157 ka square becomes a number which is greater than 4 digits. This will also be cancelled. But if you do this, 333 into 101, what do you get? 2y will be equal to 134, y will be 67. If you square 67, that becomes a number which is of 4 digits exactly. So, y will be 67, and if y equal to 67, y plus x will be 101. So, x will be 34, right? 101 has to be the sum, because y plus x has to be the bigger number, y minus x has to be the smallest number, right? So, then you have to find out the product of digits of a, b, c, d, right? So, obviously, I mean, if you square this, it becomes a greater number, isn't it? And if you square this, it becomes another greater number. So, 34 square, find out 34 square. 34 into 34 will be how much? 136 and then 102. That means 1156. If 1156 is the smaller number, obviously this, if you square it, becomes a smaller number. This will give a greater number, and greater number is 3333 more. That means you have to add 33 to each digit. So, 4, 4, 8, 9. Yes or no? I hope that is clear. You have got both. Is 4489 square of 67? It should be. So, 67 into 67 will be 9, 46, 7 6 are 42, 36, 40, right? Obviously, 4489 perfect, right? Now, ABCD is a 4-digit perfect square number if its each digit is increased by 3. That means this is ABCD. Yes or no? This is ABCD. If this is ABCD, it is asking the product of digits of ABCD. So, 1 into 5 into 6 gives us 30. Option B, 30 is the correct answer. So, very good question. Okay, it can also come, because here you first have to form this equation, break it into results and assign value to y plus x, y minus x, come up with a solid proof that this is the pair which will satisfy, and then find out the numbers, find out the answer. Okay, I hope this is clear. Find the remainder when square of the smallest 7-digit prime number is divided by 4. See, this is a question which I have discussed numerous times. You must have gone through it when you do number systems. Square of the smallest 7-digit prime number. 7-digit prime number, obviously it is impossible to guess 7-digit prime number, smallest 7-digit prime number, because prime numbers do not follow any pattern. They do not follow any AP, any GP, right? They do not follow any sequence. So, definitely, if you are dividing prime number of 7 digits, it will definitely be a prime first, and you are squaring it, and as I told you, whenever the square of any prime number is divided by 24, the remainder is always 1. So, this question can be solved in seconds. Okay, you can try it. I mean, if there is a prime number, which is greater than 3, okay, then always, if you divide p square, mod means remainder, by 24, it will always be 1. You put it, I mean, take p equals to 5, 5 square is 25, 25 divided by 24, remainder 1. Put 7, 7 square 49, 49 divided by 24, remainder is 1. Try with 11, 11 square is 121, 121 divided by 4, remainder is 1. So, any prime number, if its square is divided by 24, remainder will always be 1, and the same follows for this 7-digit prime number as well. So, not a new question, not a new, I would say, a rule. Those who have done my number system classes properly, there is a number system playlist, okay, then they would have gone through this already, right. So, answer is 1, okay. Let us go to the next question. The number of divisors of the form 4n plus 1, where n is greater than or equal to 0 of the number this. We did an exact same question where we had to find out 3n plus 1 yesterday, if you remember. So, 4n plus 1, divisor should be of the form 4n plus 1, okay. Divisors mean factors, and as I told you, whenever they talk about factors or divisors, you have to check whether this is a proper prime factorization or not. So, 10 is not a prime number, right. So, it can be written as 2 ki power 10 into 5 ki power 10. This is 10 ki power 10 into 11 ki power 11 into 13 to the power 13. Divisors should be of the form 4n plus 1. 4n plus 1. See, if they are talking about 4, this should not be there, because 2 square and onwards it is going to give you a number which will have 4 in it, and if you divide a number which has 4 in it, you get remainder 0, not 1. 4n plus 1 means when you divide a number by 4, remainder should be 1. So 2 की power 10 part completely cancels. We have to deal with 5 की power 10, 11 की power 1, 13 की power 13. See, 5 to the power anything, 5 to the power anything. If you divide it by 4, remainder will always be 1. So all powers of 5 are allowed over here. So 5 to the power 0, 5 to the power 1, 5 to the power 2, up till 5 to the power 10. All these will be allowed. Then what is allowed in 13? 13 also, 13 की power anything, if you divide it by 4, remainder will always be 1. So 13 की power 0, 13 की power 1, 13 की power 2 till 13 की power 13 will be allowed. And finally, if you talk about 11, does 11 allow the same? If you divide 11 by 4, you get remainder 3, not 1. But if you divide 11 की power 0 by 4, okay, 11 की power 0 is 1, 1 divided by 4, remainder is 1. If you divide 11 square by 4 is what? 3 square, 3 square divided by 4 is 1, remainder is 1. So that means 11 to the power 0, 11 to the power 2, 11 to the power 4, 11 to the power even number, right? You have to go till 11. If you divide it by 4, remainder is going to be 1. So we are allowed to take any power of 5, any power of 13, but only these powers of 11. How many cases are there? 0 to 10 we have 11 cases, 0 to 13 we have 14 cases, 0 to 10, 0 to 4, 6, 8, 10, 6 cases, 154 into 6, 924. That's your answer. 924. That's your answer. So these type of questions should be easy for you now, okay? You know how to make pairs, how to take powers, and how to accept them, right? How many 4-digit positive integers have at least one digit that is a 5 or an 8? Okay, so you are talking about 4-digit positive integers that have at least one digit. That should be either a 5 or an 8. Okay, now that if you talk about either 5 or 8, you can have 5 here as well, here as well, here as well, here as well. 8 also can be at any of the places. So there will be too many cases, right? If you fix 5 at units place, find out the total number of numbers, then 5 at tens place, then you find out the total number of numbers. That becomes a long process. What if we do total 4-digit numbers possible, okay? And then from that total we subtract numbers having no 5 or 8, no 5 or 8 as a digit, okay? How many 4-digit numbers are possible? See, nothing is mentioned, so repetition is allowed. 0 to 9 you can put here, 0 to 9 you can put here, 10 values, but here you can only put 1 to 9. So total numbers possible are 9,000. Total 4-digit numbers possible are 9,000. Obviously, from 1000 to 9999 there are 9,000 numbers. You want numbers now which have no 5 or 8. Okay, let's see numbers which have no 5 or 8. So we need a 4-digit number, there should be no 5 or 8. So what is allowed then? We are allowed to take 0, 1, 2, 3, 4, 6, 7, 9. Only these digits can be used, because then only, only in the case we use these digits, there will be no 5 or 8, right? On this place, how many digits can you put? 1, 2, 3, 4, 5, 6, 7, 8. 8. On this place, again these 8 digits, this place 8 digits. In this first place, how many digits can you put out of these? 0 cannot be put over here, otherwise it will not remain a 4-digit number. So 1, 2, 3, 4, 6, 7, 9. That means 7 digits can be put over here, right? So total numbers having no 8 or 5 are how many? 512, 8 into 8 into 8 into 7. 512 into 7, that is 3584. So 9,000 minus 3584 is 5416. 5416 is your answer, okay? So this is also very good question on PNC. Now let's talk about this particular question. You can keep commenting, okay? If you have any doubt in any question, I'll definitely solve it. If the sum of the infinite number of terms of the series this is equal to 1 by k, find the value of k square. Options are given, okay? All options are squares, obviously, perfect squares, because answer will be a square. 3 upon 4 factorial, 4 upon 5 factorial. If you cancel 3 with this 3 in the 4 factorial, what will you get? You will get 1 upon 1, 2, 4. If you cancel 4 in the 5 factorial from numerator, you will get 1 upon 1, 2, 3, 5. So there is no such sequence that is being generated. Can we just generalize this form? can I write this as n minus 1 and this is n factorial. So, this can be written as your finding out n minus 1 and below that you have n factorial. In fact, if you put n equals to 4 over here, n will be starting from 4, right, greater than or equal to 4. If you put n equals to 4, you get 3 upon 4 factorial, you put 5, you get 4 upon 5 factorial. If you put n equals to 6, you get 5 upon 6 factorial. So, yes, this is the general term of this series. Now, numerator we have n minus 1, denominator we have n minus 1 factorial. Can this be written as n upon n factorial minus 1 upon n factorial, right? Can we cancel n and n factorial? Yes. If you write n factorial as n into n minus 1 factorial, yes, you can write it minus 1 upon n factorial. N cancels, can you write it as 1 upon n minus 1 factorial minus 1 upon n factorial? This is something that I have broken down into a positive and negative term. Definitely, whenever we have such infinite series, either some terms cancel, right? Some terms will definitely cancel. So, now if I start with 4, because I mean obviously we can start with 4 over here, right? If I start with 4, what are the terms that I will get? 1 upon 3 factorial minus 1 upon 4 factorial. So, n equal to 4 has been put. Now, put 5. So, we will get plus 1 upon 4 factorial minus 1 upon 5 factorial. Then put n equal to 6, I will get plus 1 upon 5 factorial minus 1 upon 6 factorial. Then put 7, I will get 1 upon 6 factorial minus 1 upon 7 factorial and so on, so on, so on. What do you see here? Plus 1 upon 4 minus 1 upon 4 minus 1 upon 5 plus 1 upon 5 minus 1 upon 6 plus 1 upon 6. So, each and every term that is going to come ahead will cancel. We will finally be left with 1 upon 3 factorial, that is 1 upon 6, and we were given that sum of the series is equal to 1 by k. If this is 1 by k, k is basically 6, you wanted k square will be 36, that is your answer. Okay. So, this is a great question. Again, this is something where you have to change the format, bring it to a general form and then deal with the situation. Okay. Now, the next question is, it is known that the number 2 की power 48 minus 1 is exactly divisible by two numbers between 60 and 70. Find the sum of the two numbers. Okay, 2 की power 48 minus 1 is divisible by two numbers between 60 and 70. This is a number which can be factorized further obviously, because this is 2 की power 48. Can we write this as 2 की power 24 plus 1 and 2 की power 24 minus 1 using a square minus b square? Yes, we can do that. This cannot be factorized, but this can be factorized further. So, 2 की power 24 plus 1 and this can be broken as 2 की power 12 plus 1, 12 minus 1. So, 2 की power 12 plus 1 and then we will have 2 की power 12 minus 1. 2 की power 12 minus 1 can further be written as 2 की power 6 plus 1 and 2 की power 6 minus 1. 2 की power 6 minus 1 can further be written as 2 की power 3 plus 1 and 2 की power 3 minus 1, because 2 की power 3 minus 1 cannot be factorized further. What do you see here? 2 की power 3 minus 1 is 8 minus 1 7, 2 की power 3 plus 1 is 9, 9 into 7, 2 की power 6 64, 64 plus 1 is 63, sorry 65, 65, yes, 65, okay. What do you see now? This is a number which is greater than 60, 70, right? So, there is no point writing them. The question wanted us to know, to get the two numbers between 60, 70 which divide this. Obviously, one of the numbers will be 9 into 7, because 9 into 7 are present in the factorization of this. So, 9 into 7, 63 will be one number, another number will be 65, because obviously 65 is present here. Can you generate any other 2-digit numbers between 60 70? No. 65 into 9 is greater, 65 into 7 is greater. You cannot do that. Only these are two numbers between 60 70 which are dividing this. So, their sum will be 60 65 128. That is your answer. Okay. I hope this is clear. This is also an easy question. Okay. Okay. This is your homework. Fine. This is a question on discounts. Do give it a try. Very good question. And also this is your homework. Fine. That's it with the day. Give it a try. I hope you like the questions. And we have done so far, I mean we have reached 69th question, almost 70. Probably within next 2-3 days we will touch 100, and probably very soon by the end of March, last week of March, we will be finishing with these 250. Okay. So, let me know if you want me to include something else in this series, okay, some other topics that you want, and do subscribe to the channel, okay, like this video, share it with your friends, do comment if you have any issues, fine. And the crash course is starting from 29th of March. Do join it if you want a rigorous revision, rigorous practice with iQuanta. Okay, in that crash course, we'll be starting the classes from very basics, and we'll be solving a lot of questions. We'll have late night practice sessions as well. And as we delivered 20 plus questions in the last 2 years, 2024 and 2025 IPMAT Indore, we hope to deliver even more this year. Okay, so thank you so much, keep watching.